What is up, intermediate algebra students? This is Krupstat, and we are going to be talking about factoring special cases. So there's 3 special cases you should be aware of, although in most cases there's nothing really special you need to do with them, but they are something that sometimes something weird happens. So let's talk about them. Here, we're going to start with this one. If I gave you this problem, factor x squared minus 81, you might scratch your head a little bit when you get started because you're missing some things. So traditionally when we are factoring things in standard form, which is ax squared plus bx plus c, where we have 3 terms. And in this particular polynomial, we do not have 3 terms, we only have 2. So which term are we missing? Well, we have our 1x squared, which is our a, we have our minus 81, which is our c, and so we're missing this x term, which means if we don't have that x term, we have no x's, so we would put a 0 there. This then can be factored exactly the same as how you would factor any other problem. I'm going to move this box over a little bit. We will create a box. We will put our first term in the first box and our last term in the last box. And then we're going to create that table where we need 2 numbers that multiply to a times c, which is negative 81, and add to our middle number here, which is 0. This is one of these awesome situations where anytime we add to 0, we know our numbers need to be opposite. Now, I could write down all the factor pairs of negative 81, but if I know they have to be opposite, I can think about the fact that the square root of 81 is 9, or 9 times 9 is 81, which is also happens to be the pair that adds to 0. So my magic numbers are 9 and negative 9. And then I'm going to work on getting outside of the box. So I have x times x, which gives me x squared. Positive 9 gives me 9x, and negative 9 gives me negative 9x. So my factored form is x plus 9 and x minus 9. So this is kind of a special case for a couple different reasons. First off, you're missing that middle term. Second, you end up getting where you're adding to 0 and you're looking for those opposite numbers. And then lastly, our factors look very similar to each other. One is a plus and one is a minus. So this special case is called the difference of perfect squares. And there is a formula and a quick way you can factor the difference of perfect squares. If you are interested, I'll show you an example. But really, the recommendation that we have here in the notes is that you just put a 0x as that middle term and you use the box to factor. That makes it so you don't have to memorize any new rules. Now, if you want to memorize a very quick way of factoring, let's do another example. One thing as you get more experience is you will notice that since the middle term has to cancel out, I will know that I will need these 2 factors to look exactly the same. So the first 2 spots will have to be x times x, because that's going to give you my x squared. And then I'm going to think about what times what would give me negative 100. Well, that would be a positive 10 and a negative 10. And there's the factored form. Here's another example. If I had 4x squared minus 25, I could go through the box if I wanted to, or I could recognize the fact that the middle terms are going to cancel out, so my factors are going to look exactly the same except for opposites. And I'll start with 2x times 2x will give me that 4x squared, and then a positive 5 and a negative 5 will give me the negative 25. So they're pretty quick to factor if you know the trick. However, you do not need to memorize that because the box will always work. Let's look at special case number 2. This looks like a very traditional trinomial that I would factor. So let's go and do this. So I would put 4x squared in that first box and 9 in the second box, or the last box. Then I need 2 numbers that multiply to 4 times 9, which is 36, and they will have to add to my middle number, which is 12. My options are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. All right, well, it looks like 6 plus 6 is my winner for the adding to 12. So my magic numbers are 6x and 6x. Now already you might be thinking, oh, that's kind of neat, right? They're the exact same number. Well, it goes even further because when I start factoring this and figuring out what goes outside the box, I'm going to have to use a 2x and a 2x here because using a 4 isn't going to work with that 6x. Well, that makes this a plus 3 and then this side a plus 3. So the factored form for this one is 2x plus 3 times 2x plus 3, which if you notice, these binomials match, so I can write them as 2x plus 3 squared. This special case is called a perfect square trinomial, and your answer will always end up being something squared, a binomial squared. There are formulas here that you can learn if you would like to. However, these are a lot more difficult to spot just by looking at the problem. So our recommendation is, since it's just a regular trinomial, is to factor it exactly the way that you always have using the box. And just remember that when you have two factors that match, you could write it as that factor squared instead. Let's look at our last example and special case. Again, we have a fairly traditional trinomial, 3x squared and 2 going to go there. I need two numbers that multiply to 6 and add to 6. All right, so I got 1 times 6 and 2 times 3. Well, I know they have to add to a positive, so I'm going to keep them positive, but it looks like no matter what I do to add these together, I am not going to get a sum of 6. I can't think of any other numbers that would possibly multiply to 6 and then add to 6. So what do we do when there's no magic numbers? Well, it's very possible that this trinomial is not factorable. When it's not factorable, we call it prime. A prime number is something that cannot be divided by anything besides itself or 1. So technically, we could factor this into a 1 times 3x squared plus 6x plus 2, but that really doesn't change anything or make it into different pieces. So there's no sense, right? Now, in order to determine if something is prime, you need to make sure that there are no magic numbers that work. You have to check all the possibilities. So this is where that process of writing down those factor pairs is really important so you're not missing one. Those are your three special cases. Good luck and have fun.